Welcome. Here we are going to look at one of the interesting questions under rotational motion. And the question says, find the expression for the angle of inclination for the sphere of mass M rolling down the incline of length L starting from rest and reaches the bottom of the incline. So here we have been given this sphere which is on top of this incline. And when it rolls down until it gets to this point, okay, until it gets to this point. Now, we are going to find the angle of inclination. And the energy that is possessed by an object due to its position is potential energy. So this one here, it is having potential energy. And when it rolls down from here, getting to this point, then this one energy is going to be converted in other forms or to other forms. Because being a strong believer of the conservation of energy, we know that energy can neither be created nor destroyed, but can only be converted from one form to another. So this potential energy, which is here, this potential energy will be converted into kinetic energy as it rolls down, as it comes. Because kinetic energy is the energy that is possessed by a moving object. So as it comes down, the potential energy will be converted to kinetic energy. So that one, using the energy conservation principle, we can find the expression for the angle of inclination. So we say using all the total energy, this one will be converted to, when it begins to move, this energy will be converted to kinetic energy. So this one we're going to have potential energy is equal to kinetic energy. So total potential energy is going to be equal to kinetic energy total or so. So here we are going to have, we have this one due to this height, we have mgh. When it comes down here, there will be no potential energy, or the energy will be converted into other forms, which is kinetic energy. It will be converted into kinetic energy. So we are going to have kinetic energy rotational plus kinetic energy translational. So it is like this because as it rolls down, it will be rotating as well as covering some linear displacement. So no wonder it is like this. Let us plug in the formula, like what we know. mgh is equal to, so rotational kinetic energy is given by half moment of inertia omega squared plus, so this one for translational kinetic energy we have half v squared. But we know that moment of inertia for a solid sphere is equal to this. And at the same time, we know that v, which is linear velocity or translational, okay, linear velocity is equal to r times omega. Let's transform this one so that we have over r over r. Omega will be equal to v over r. So putting this one and this one in this equation here, what we're going to have is times 2 over 5 mr squared. Then this one, it is this, so when we square it, we're going to have v squared over r squared plus half mv squared. mv squared. But we're able to see that this and this can go, this and this can go. And also the masses are common, so we can cancel this, we can cancel this, and we can cancel this one. What we're going to have is gh is equal to v squared over 5 plus v squared over 2. From this point, let us try to finish if we can. So here we have gh is equal to, here we have the common denominator, or the lowest common factor here is 10. So 5 into 10 is 2. 2 times v squared, it is v squared plus, listen to this, it is 5 times v squared, 5v squared. From this point, we're able to see that gh will be equal to 2 plus 5, it is 7v squared over 10. So let us now work let us now do some mathematics. So this expression, let us call it asterisk 1. Asterisk 1. So for this one, let me just erase this as that. Here we have this angle, and this is the side that is opposite to this angle. So we know that sine theta from this SOHCAHTOA from so is equal to opposite, which is this one, h, over hypotenuse, which is this one, L. So this one, if we make h the subject from here, we're going to cross multiply and we're going to have h is equal to L sine theta. So where there's h, let us call this as asterisk 2. Asterisk 2 into asterisk 1, we are going to have g L sine theta is equal to 7v squared over 10. So from this, we can divide by GL, and here the same GL. So that GL and GL will go, and what we're going to have is sine theta will be equal to 7v squared over 10 GL. And for the angle of inclination, it is simply theta is equal to sine inverse of everything here now. 7v squared over 10 GL. That this will be the angle of inclination. If we have some values, try to put them here, and what we're going to have is this angle of inclination. Thank you so much for watching the video.